A very good morning, good evening, good afternoon to all my friends and students, dear students. This is the 37th class. So, we will have 37th, 38th, 39th, 40th, and that would be the end of the project management. And as you know that I mentioned that the GERT, Q-GERT would be the last portion of these lectures. So, I did mention it quite long time back when we were in the initial stages. And in the last class or last to last class, both the classes we were discussing about GERT, the exclusive OR, the inclusive OR, the AND gates, the logics, and how the logics could be brought into the picture for the GERT concept, and how it is different from the PERT and the CPM. So, just to recapitulate, even though I am sure all of the students are very intelligent enough, they have gone through the lectures, they have understood the concepts thoroughly. So, just the basic point is that if you remember in critical path method, the time was fixed deterministic, based on that we found out the time. In PERT, time was stochastic with a certain distribution, and based on that we found out the time for the critical path, then hence resource constraint when they came, it was necessary for resource leveling, resource scheduling, and how we use the central limit theorem to find out the time to finish a certain number of days completed, that what was the probability of finishing a certain percentage, or vice versa, in the sense that I want to finish certain percentage, what was the date based on which I could at least pass some comments related to that. Then the third point was that how the crashing could be done for each and every job and activity or collectively, such that we could aim at a minimum requirement of resources in the concept of time. Then when we came to GERT or GERT, whatever you call it, we considered another important aspect was time was probabilistic, but the probability of whether a path would be taken was also probabilistic. So, there are two attributes or two characteristics based on which we started discussing. Then we discussed about the launching of a satellite, of a rocket, and how it could be made much more realistic, in the sense that there would be different type of issues related to the jobs and activities taking place, not taking place with certain probability levels. So, continuing with the discussion, so we will try to discuss in more details in this 37th class, and then at the fag end of this course try to go into a detail about a problem. So, one of the niceties of GERT, as the slide says, is its usefulness at many level within a problem area. So, we will be switching the slides due to the fact that we will try to bring the concept of exclusive OR, inclusive OR, and corresponding to the fact that they can be three different ways of trying to analyze the input criteria or the input characteristics. With respect to the output characteristics were 2 in number. So, all the combination, if you remember, I did mention time and again, it was 3 into 2, it was basically 6. So, consider the problem in much more details. So, what we have, if you note down, we have the assembly, then the receipt of the subsystems are there. So, when you are assembling, there could be different type of subsystems which are being assembled in order to get the product. Product mean, like I am trying to build up the cryogenic fuel tank or the solid fuel tank, and they would be inputs like, say for example, what would be the engine which will basically give the first thrust. Then the other thing can be, say for example, how the heat dissipation can be done. Third could be how the different levels of pressures could be monitored using some very sophisticated pressure valves. So, those can be the issues, and those are the subsystems which should work properly one after another in such a way that the overall the assembly is done properly. Then once the assembly is done, it goes into the base facility. So, what we are trying to do that we are trying to expand the overall analysis of the project into more details. So, we can understand the different type of jobs or activities or tasks which are necessary. Then after the assembly, we basically get all the facilities from the base station, whatever it is, can be manpower, it can we are trying to utilize some different type of CNC machines, different type of robots which may be required for doing some sophisticated work. So, all these things are basically conglomerated, and once this is done, you basically check it out, the things are working properly on a standalone basis, combine them and then go for the terminal countdown. So, if you notice this, the diagrams, I will again come into the description in more details. If you notice these diagrams, they are a conglomeration of these 6 different concepts of input output combined. So, 3 of input and 2 of output combined. So, let me again recapitulate and go back to the slides. Okay. So, the combinations were, so this chart if you remember we had discussed that considering the different type of inputs outputs. The first one is the exclusive OR plus the deterministic one, exclusive OR being the input and deterministic being the output. Then you have the exclusive OR or probabilistic, then again input output. So, the first one is the input, second one is the output. So, you remember that, but just I am mentioning that for our own convenience. Then you have the inclusive OR deterministic one. The fourth one is, which is basically the rhombus is the inclusive OR plus probabilistic output. Then you have the AND the deterministic, AND means the input and the deterministic output, then you have the and probabilistic output. So, if you consider that, and I will just pause here for another few seconds. So, the students can have a good look at all the combinations which are there. So, the 1, 2, 3, 4, 5, 6 which is 3 inputs multiplied by 2 outputs combinations, you get these diagrams. So, coming back to our problem description more in a qualitative framework such that the idea gets much more clear. So, you have the terminal countdown where I am pointing my finger, and based on that you have the concepts where it goes to the orbital correction achieved and the successful orbit being achieved. Then you have the boost phase of the rocket, and one of them if you see here there is the unsuccessful orbit being achieved, which means there would be an unsuccessful stage there. And based on that the failure phase, flight failure phase inputs which take place, because you remember, just not to disturb the flow of this discussion, if you remember I did mention time and again that the concept of looping is not there in POT CPM, but that is a big negative point in the practical sense that looping is necessary in many of the projects and many of the network flows. So, if you bring that concept into GERT or GERT or Q-GERT later on, so you will find that looping concept is a part and parcel of the discussion such that it makes sense in order to implement many of the practical problems in a very nice way. So, on the other hand, if you had no such problems, so the base diagrams which I am showing, if you have no such problems, they would be, if you notice the topmost the node set of nodes, so called nodes and the arcs, there is a successful launch, and after the inputs which are taken care in the lower half, there is a successful launch, because feedback loops would basically help in doing that. So, what we are actually trying to highlight in this diagram is that the nitty-gritties of each state can be made to the maximum possible extent considering the looping, and the 6 different combinations of 3 inputs and 2 outputs are done to the best possible manner such that any level of complications can be considered in the GERT diagram. So, we will basically continue the discussion with related to this diagram and to the discussion which we had in the last class related to the successful launching and unsuccessful launching of the spacecraft or into the orbit. So, the first point is that AND node plays a predominant role in the activities up to and including the terminal countdown. So, whenever you are trying to analyze the problem, not this only, but any problem, they would be that, say for example, a process will work, or say for example, a stage will start depending on the combinations of the activities which are there beforehand. Now, the combination of the activities can be either based on the AND, that means both have to be basically performed such that you can get the output, and it can also happen on the case that one of them is possible, then basically you achieve the target. So, consider this stage like in an exam, very simple example is not related to a project, but basically consider this logic. You are taking an examination and there are two papers. Now, consider it states that you can only get the pass mark provided you have to pass in both the examination, that means paper A and paper B. That means your requirement would be you graduate in paper A and as well as paper B. Another combination can be that you graduate the examination. They can be scenarios, I am just trying to basically highlight the hypothetical example. Another scenario would be that you will graduate the examination the moment you graduate or pass in any one of them. Say for example, the pass mark is for any examination is for both case 1 and case 2 example which I gave is 40 marks out of 100. So, even if you get 25 in paper B and get say for example 40 or 41 in paper A, you will graduate in the examination considering the scenario 2. So, obviously, it would be a situation where either paper 1 or paper 2 would basically qualify for your case where you basically pass the examination. In the first example or case 1 which we stated, which means that you have to achieve 40 minimum in both paper A and paper B in order to graduate into the examination. So, this concept of AND or would basically depend, or if you basically go into details of exclusive or inclusive or, as we had mentioned in the diagrams with the so called tables of true and false. So, those truth tables only considering A and B as the activities or A and B as the switches. Based on that, we can basically make our diagram as complicated as possible, provided we are able to bring all the practical applications into the picture. So, in this diagram, so if you go back to this diagram which we have just discussed about nitty-gritties of how the countdown and all the complications can be achieved. So, this is an AND node, it plays a predominant node. This is due to the fact, which is the second point I am leading, this is due to the fact that all the activities must be performed before left off, which means that all have to be performed, all have to be done successfully. If and only if all of them are met, then only the next stage basically is achieved. So, as I mentioned in the examination taking case of you as a student, so you would only graduate if you pass both the examinations. So, this work or this launch can only happen if the precedence jobs and activities, all of them are completed. After the terminal countdown, either possibilities are presented. So, after it is done, so if you can only go for the launch if all the work is done, point 1. Point number 2, when you launch, the success of that project would be either yes or no. That means, either the launch can take place or the launch cannot take place. So, if you consider the collectively the launching of that satellite or that rocket, it would mean that there would be some combinations of AND, some combinations of exclusive OR, some combinations of inclusive OR, such that collectively all the logic gates or the logic would be into the considered into the diagram in order to give the best picture for the practical problem which you are trying to solve. Again, and continuing our discussion for this diagram, successful node is an inclusive OR node due to the reason. So, when you basically consider the diagram, so that is an exclusive OR node or the job which we are considering, due to the fact or the reason that successful launch can happen in two mutually exclusive ways. So, which I just mentioned just a few seconds back. So, what are those reasons? Proper operation during boost phase. So, the boost phase is basically just before the takeoff, when the cryogenic rocket or the fuel tank and all the fuel are basically ignited as per the technical norms, and then they lift off once basically meets all the criteria. And another one is that unsuccessful orbit after boost phase, which with orbit correction achieved. So, you are considering now different stages. Once you lift off the rocket, so lift off the rocket means you have been able to put forward the rocket into the space. But there are other work also, like say for example, if the rocket goes within satellite, it may so happen that in the later stage the satellite may not be successfully launched into the orbit. So, if you consider the whole project as such is a failure, but the initial work are success. Another scenario can be the satellite is successfully launched in its orbit, geostationary satellite, consider that is put around the earth in the successful way, but in that case all the stages have to be successful. So, if you consider part by or in the whole holistic sense, the success will be defined depending on what your actual target is. So, in the initial case combining all the jobs in order to basically first put the spacecraft into its flight mode is or can be considered as success. If I consider the whole problem in a sense that even though if I am able to put that satellite into the orbit, but the malfunctions, so obviously it would mean that collectively it is a failure. So, if I basically go into the details, just zoom in onto the diagram. So, you have basically the preparatory actions, if you remember the leftmost portions of trying to combine all the different jobs, and then basically you test it. Now, when you are testing it, so that detailed discussion I did not do, when you test it there may be some problems. So, what will happen is that, which is totally different from the PERT and the CPM network, is they would be input loops, again coming back to the combination of the stage where you basically combine the different jobs in order to basically be prepared for the test phase. So, what you do, and if you consider this loop, is that you return to the start of the test such that any malfunctioning of the whole process when it happens during the test can be included in the study, such that they give a good picture that how the inputs can be utilized from the test, and the how the outputs from the test basically acts as a set of information for the inputs in the later stage. So, this loop can continue till you are able to achieve the goal which is set for this initial stage, which is the test stage for our consideration, such that once the feedback loop is complete in all its proper implications, you are able to incorporate the feedback such that the test phase is successful. Then if you continue with the looping and go beyond that, they could be a diagnosis based on how whether there is an actual problem. So, they would be basically two type of problems. One is they are not that detailed, they can be handled, and this handling is done by the looping which is there. So, all the looping considers that the feedbacks are such that they are able to take care of these errors. And then obviously, if you are able to take care of all the errors, it goes into the continue and the countdown stage and the later phase of trying to basically put the satellite into the orbit. So, obviously, there would be other stages on to the right, which is not shown, which is cut here. Another issue can be, say for example, when you are trying to analyze the problem, there can be an issue which cannot be solved in the test phase. So, consider there is a major flaw in the diagram, or there is a major flaw in the design of the cryogenic fuel, or there can be major problem in one of the valves. So, in that case you have to basically do a detailed diagnostic test get the feedback and basically go into the preparatory actions, as that those preparatory actions may now be affected depending on the feedback which you got. So, internal feedback was not successful, say hence the issues of the feedback would basically be considered on a much bigger scale, such that the pre-work which is needed before the test phase, which is mentioned here as preparatory actions, should be considered in more detail to take care of the problem. And obviously, if everything is fine, you follow the set of nodes and arcs which is there on the top portion of the diagram where I am hovering my fingers. So, that will give you the terminal countdown and how the work starts. All the 6 nodes. So, now coming back to the concept of 3 input and 2 outputs. So, all those combinations. So, all the 6 nodes behave in the same manner if only one branch is received at the input side and only one branch is emitted at the output side. So, whenever you are trying to combine, and if there is only one input and one output as stated in this point, so it will mean that the combinations of all the 6 nodes or the behavior of the 6 nodes would be exactly the same. We will see that as we discuss, it will become clear to you. Thus, if 2 branches are in series, so now the work can be done in series or parallel. If you remember very basic concept of what is a series circuit versus a parallel circuit. So, obviously, they would be, if you consider the precedence diagram for the PERT, CPM, based on the fact you have been able to draw the diagram to the maximum details using the Gantt chart concept. So, there would be some jobs which can run parallelly. So, we will consider them to be in parallel, and then some jobs would basically have a very strict precedence and successor concepts, such that one job can only start once the other job has started, or one job can only start once the other job has finished. So, in that case you will basically have the concept of the series. So, that is what we generally mean by the concept of series and the parallel concept of the jobs in the network concept. Thus, if 2 branches are in series and they are being considered, then the node type have no effect on the equivalence of one branch on the network. So, depending on how the work works, it will basically have an implication. The reason being that, if you remember the initial discussion which we had about the different concepts of 3 inputs and the 2 outputs, that will make a sense, because in one of the diagrams. So, let pause here, I will go back to this detailed table once again to refresh our memories. So, if you come back to the 3 inputs, so it means that if you read the characteristics, that will make it clear. So, the first one says, which is an exclusive OR, that it says that only one and only one of the branches leading to the node can be realized at a given time. So, they would be only one. So, depending on the realization, it will basically depend on which one of is taken. The second one, which is the characteristics which I am going to talk about, is, and repeat, is for the inclusive OR. It mentions, if you read it, the time of realization is the smallest of the completion time, which means that you will take the minimum of all the times and proceed accordingly. So, the discussion which we had just few minutes back, depending on the combinations, would obviously mean that either you take the minimum time or the maximum time. Now, the point of maximum time is coming here, or the realization would be coming here. If you read the last characteristics of AND, it stated the time of realization thus is the largest of the completion time of the activities leading into the AND node. That means, all of them combined together would only be achieved, and such that the next stage is achievable, or the next stage of the job or the activity is active. So, in that case, all of them have to be done in such a way, the moment the last switch is put on. I am considering the switch as a very simple concept of the job, and once it is completed, then only the rest of the whole project can start. So, if you read these characteristics once again for a better understanding, you will understand what I am basically going or discussing through. So, this which I am saying, after the terminal countdown, third point, after the terminal countdown, either possibilities are presented, and based on that we proceed. Now, continuing the discussion, successful node is an exclusive OR node due to the reason that successful launch can happen in two mutually exclusive ways, which are proper operation during the boost phase. So, when you are trying to boost the engine of the rocket and then put it into space. So, if everything is working properly, then only the exclusive OR node would be there. And another thing could be the unsuccessful orbit after boot phase with orbit correction achieved. So, in both the cases, if there is unsuccessful task or job, obviously there would be a feedback. Once the feedback comes, you will basically take corrective actions. So, once the corrective actions is taken, we will consider the work has been solved and then we will proceed to the next phase. So, in this both cases, the exclusive OR would mean that you are able to take care of whether it goes past the yes phase. Yes means everything is correct at one go, even if there is some no or some false or some zero implications is there. The word false, zero implications or problems, I am trying to basically use that interchangeably. So, please bear with me. So, if they do not work, obviously it would mean that it would be a feedback. Feedback basically feeds into and gives us the information for the preceding jobs or activities based on which we take the action. So, exclusive OR would be applicable in both the cases. And the dotted lines basically represent the process where it signifies activities that do not contribute to the successful launch. So, there may be some stages or some set of work which would not lead to a successful stage. So, we are trying to basically differentiate that with dotted lines. So, these are basically a nomenclature we are trying to utilize for the arcs in order to make things much clearer to us. So, for the dotted lines which you mean is basically this one. So, where I am hovering my finger. So, this if you see the boost phase is a failure. So, obviously, it would have no consequence on the successful implication for those set of jobs or activities. So, this is the diagnostic one and the feedback loop which were considered based on which we proceed. An equivalent network, so basically considering our discussion. So, we will now basically go into some detailed definitions. An equivalent network is defined as a reduction of a multi-branch network into a one branch network, where the parameters of one branch networks are derived from the parameters of the branches of the multi-branch. So, what we are doing is that we are trying to basically replace the multi-branch in whatever complications it is with the basically fixed branch. Now, there I will pause and basically try to go back to one of the concepts which we did discuss when we were considering the decision trees. If you remember, I did mention about utility functions and I also did mention about certainty equivalent. So, if you remember, in the certainty equivalent or utility functions, we had one important concept was expected value. If you go later back to the projects, there was net present value or the expected value of the project, so or the earned value. So, what it means that you are trying to basically find a one-to-one implication of the complicated network with a much simple network such that the overall feedback loop or overall logic circuit in this GERT concept remains the same, which is in some way trying to basically draw a one-to-one correspondence with the concept that whatever complicated utility functions which you have or whatever complicated decision trees you have, you are trying to replace that with a deterministic one such that the expected value of both of them are same, considering that the characteristics of the investor or the decision maker you are. So, with this I will close this lecture, and thank you for the attention, and we will continue discussing the GERT in the last 3 lectures, which is the 38th, 39th and 40th, with some implications for the practical purposes. Thank you very much.